So let's go through this one. This one was tricky, and we're having a lot of troubles adding positives and negative numbers. That's why I chose this one. But looking at this, I'm going to ask you a question. Is there any multiplication in here at all? No. Not really. Nope, there's not. I mean, 2 is multiplied to x. I guess we want to get technical, but this is 2x plus 3x minus 3 plus 4 plus 5 minus 7 minus 4x. So guys, with adding and subtracting, remember order of operations, and Sally actually go hand in hand. So if you add and subtract in any order, you'll get the same answer. So we're going to go through and combine like terms carefully. So I'm going to kind of think in sections on this one. I really think it's going to help us not make any errors. So we have 2x plus 3x minus x. Let's focus on that for a second. 2x plus 3x is how many x's? 5x's minus 1x is? 4. How many got at least that part right, and maybe you add it differently so you're not quite sure yet? A lot of people got that part. Okay, now let's focus on our numbers for a second here. I have negative 3 plus 4 plus 5 minus 7. Let's add that up. What's negative 3 plus 4? 1. Positive 1 plus 5 is? 6 minus 7 is? Good, negative 1. Awesome. Okay, moving on. We won't forget about our negative 4x floating out here. All right, so combining like terms, last thing. 4x minus 4x, how many x's? 0. 0 x's. So we don't need to write 0x, it's gone. So then left is just negative 1. Okay. How many of you got it right? Raise your hand. No one? No one? Oh, 1, 2. Okay. How many of you were super close? You just made a teeny little error, now you see it. Awesome. That's good. You see what you did wrong, and no questions on what you did wrong. You're getting it, just a little error. Okay, guys, so we just got to be really good. We're getting better, definitely, from day 1 to now. We're getting better at adding and subtracting positives with negatives, negatives with negatives. We got to keep staying focused and practice on those, though, because they're going to bite us in the butt eventually. Okay, here we go. Let's go to our new lesson. You should have your stuff ready to take notes. Please get that out. Now, once again, there is no one in this class that's just smart enough, I promise you, just smart enough to not take notes and remember everything I teach you. Now, you don't have to write down every single thing I write, but you can be taking notes like, hey, remember this or that. Okay? You should all be taking at least something. I promise we're not learning so little that you can't just not take notes. Okay, so today's lesson will be, if you want to title your notes, it's going to be 1.2.3. And we're going to be doing a lot of things today. But before we start, I want to talk about some vocabulary, because if we don't understand some vocabulary, when I say something, you're going to say, what do you mean? What is she talking about? It's not going to make sense. So, and once again, these things are super important, so pay attention to the vocabulary. So first of all, like terms. We know how like terms work. We have been using them, but we've been doing like terms with all linear terms. So we've been combining like terms with linear terms. But let's first of all talk about this. Okay, so like terms have the same base and same exponent. Like terms have the same base and same exponent. We're getting the gist of that. Okay, and the rule is, if we have like terms, we can combine them. We can add or subtract like terms. Okay, so we in this class so far have only seen linear like terms. So something like this, 2x plus 3x. Now, before we do that, the reason, so some of you are like, what does she mean by linear? So I'm going to tell you just quickly. This is degree 1. Does everybody see how there's a 1 up in the exponent of x? And this is degree 1, technically. So that means linear, because this, if we were to graph this, it would be a line. Okay, so just keep that in mind. We've been combining like terms of linear terms. But like terms work all the time, no matter if we're dealing with linear terms or not. Okay, so let's do this one. We know how to do this one very easily. 2x plus 3x. What is it? 5x. 5x. I'm so glad you guys didn't say 5x squared. The only time we're going to ever add, oh, I wrote 5x squared because I said it. I'm so glad you guys didn't say 5x squared because we are not multiplying. We're not multiplying, right? If we were multiplying, then we would add the exponents. But since we're just adding, you'll simply add them. All right, so let's look at this one. 2x squared plus 3x squared. How many x squareds do we have? 2x squared plus 3x squared. How many x squareds do we have? 5x squared. Very good. Now, once again, we weren't multiplying, so we're not going to add the exponents. You guys, I've been actually very impressed because most of you haven't done that. And that's usually something that secondary 2 students start out the year doing. So very good. You guys understand the difference between addition and multiplication. Okay. 2 ABs plus 3 ABs. How many ABs?
5.
5 ABs. That's a true statement. All right, and then 2 apples plus 3 apples is 5 apples. Okay, that was just one of those funny, dumb examples. Okay, 5 apples. Okay, very good. Doesn't look quite the same, does it? It doesn't look quite the same. Okay, very good. Now, what if I would have changed this? We've got to pay close attention in secondary too, because you're going to see both all the time. If I would have changed that plus sign to instead a multiplication sign, then it would be a totally different answer, right? It would have been 2 times 3, which is 6, and then x times x is? No. X plus x is? X what? Squared. Very good. When you multiply the same base, you'll add the exponents. Only with multiplication, though. Okay, let's go through and talk about term. Okay? Term is a number or variable separated by a plus or minus sign. So I would write this down. Super important, and I guarantee on the end of level tests, you're going to see this come up. They're going to say, how many terms does this have? You're going to see it on an ACT. It might say, how many terms does this polynomial have? If you're like, I don't know what a term is, you're going to get it wrong. It's actually really easy if you know what it is. Okay, so a term, once again, is a number or variable separated by a plus or minus sign. So you could just write something separated by a plus or minus sign. So we're going to go through and look at these individual polynomials and decide how many terms they have. 2x. Now, one thing I want to point out, you can't go through and count the plus and minus signs. That won't work. You'll get the answer wrong. You've got to count what's in between the plus and minus signs. So, for example, with 2x, this is one term. There's one thing in it, in the polynomial. There's one term. So we have 3x plus 2. So 2 terms here. So 2 terms. Any questions on how I got 2 terms? There's one plus and minus sign. Terms are separated by a plus and minus sign. 2 terms. How about 3x minus 4? You tell me. 2 terms. Very good. All right, let's look up here. 3x squared plus 2x minus 5 is how many terms? 3. 1, 2, and 3. Awesome, you guys are getting it. And we're getting there. Now, I'm going to ask you, 3x plus 2x, before you add it, how many terms?
2.
1, 2, you're right. Before we added it, there was 2 terms. Now, we know we can combine like terms, so we add those together and get 5x. How many terms would it be then? Once we simplify, there would be 1 term. Okay, awesome. You guys understand how terms work? I'm sure that was pretty simple here. Okay, next vocabulary word is coefficient. Guarantee you'll see this. Okay, so 7 out of 10 tests on an ACT will contain a problem that asks about coefficients. So almost every single ACT test, there will be a question on coefficients. On the end of level, you'll see it. So we gotta know what a coefficient is, okay? So a coefficient is the number in front of the term. So once again, a coefficient is the number in front of the term. Now notice I put in parentheses. With a coefficient, guys, it's not the variable. It's the number in front of the term, not the variable. So we've already went through and decided on all of these polynomials, how many terms we have. Now we're going to list the coefficients. So my first example here, 2x. The coefficient on 2x would just simply be 2. Very good. That had 1 term. It has coefficient 2. So looking at this, 3x plus 2. This has 2 terms, and it also has 2 coefficients. So it's not the x, it's the number in front of it. So 3x is, what's the coefficient in front of that? 3. And then right here, this is still a coefficient, guys. This is called, interesting enough, listen up, because you're going to see this again. This is called a constant coefficient. So it's just a constant number. There's no x's attached or anything. It's still a coefficient. It's a constant coefficient. So this is positive 2. So I'm just going to write 2. We have 2 coefficients, 3 and 2. All right, looking at this one, we have 2 terms. We're going to have 2 coefficients, 3 and -4. I'm so glad you said -4, because if we wanted to get technical, we could say that that's 3x plus -4. Same thing? Yeah. Okay, looking at this one, 3x squared plus 2x minus 5. This has 3 terms. Now, before you answer, think of what I'm asking. What's the coefficient in front of x?
3. 2. 5.
I'll ask again. What's the coefficient in front of x?
2. 2.
2. Good. Everybody look at x. The coefficient in front of x is 2, okay? What if I asked it like this on the test? What is the coefficient in front of x squared?
3.
It's a 3. Does everybody see it? Now, what if I asked on the test? I can guarantee you're going to see this asked on our first test. Something like this. What is the constant coefficient of the following polynomial? So if 3x squared plus 2x, what's the minus 5? What's the constant coefficient?
Minus 5.
Good, negative 5. Constant coefficient is the number that doesn't have any variables. So that would have been negative 5. All right, now depending on how I asked it, you would get different answers. So if I just said what are the coefficients, you would have done 3, 2, and negative 5. Okay, I just wanted to test your knowledge on understanding the difference between the different types of coefficients. All right, 5x has one term. What's the coefficient?
5.
5. Good. 5. Okay, now we can move on. All right, so now we're getting to the nitty gritty. Here we go. Today we're going to be multiplying polynomials. So we have seen some stuff like this in previous classes. We're going to get harder in this class, and then guess what? Secondary 3, we get even harder. We're going to be seeing this all year. If you're going to see it on the ACTs, you're going to see it on end of level. So we got to get good at this stuff. Okay, so we're going to be multiplying polynomials, and we're going to start out basic and then move our way up. Okay, so looking at our first example here, we have 2 times 4x minus 3. Okay, now notice I have a constant number multiplied to a binomial. Binomial, guys, just means 2 terms. Does everybody see how 4x minus 3, that's 2 terms? So we're multiplying 2 to all that stuff. So what we're going to do here is we're going to distribute that through to both terms. So I would just suggest drawing my little rainbow. I have a math degree, guys. I still draw that because it takes me 0.4 of a second, and I never miss it if I draw my little arrows. So 2 times 4x is 8x. Now we're going to have to pay attention to details today because we don't want to make any sign errors. With this stuff, there's lots of errors that happen, but not today. Okay? 2 times negative 3. Good, negative 6. Very good. So we're going to pay really close attention to negatives and positives and negatives and negatives. And that's our final answer. Can we combine 8x minus 6? No, not like terms. Next example, 3 times 2x plus 4. Once again, a constant number multiplied to a binomial. So let's go ahead and distribute this through. Negative 3, careful, times 2x. Think before you answer.
Negative 6.
Good, I'm glad you said negative 6x. That would be true. Questions on talking about negative 6x? Okay, negative 3 now times by positive 4.
Negative 12.
Okay, awesome. Negative 12. Very good. I'm glad you were able to see those signs correctly. We're going to be careful today, right? Yes. Okay. All okay with that. Let's do a little bit harder. This is where the most common errors come in. Right here. Ones like this. So notice, in this case, I have 2 times x minus 1. Once again, now this is a monomial, meaning 1 term multiplied to a binomial, 2 terms. 1 term multiplied by 2 terms. We've got to multiply all that to all of that. So I'm going to draw my arrows again. So 2x times x. Now careful. What's 2x times x? 2x squared. Good. X times x, when you multiply the same base, you add the exponent. So 1 plus 1 is 2. 2x squared. Awesome job, guys. Now 2x times negative 1. Negative 2x. Beautiful. Now, one of the most common errors is people forget to write that x there. Negative 2x times that is always going to have an x, right? Okay. Very good. Any questions? Okay, let's do another one where we have to be careful. Every single one will have to be careful. Negative 4x, a monomial, 1 term multiplied to a binomial, 2 terms. All right, let's take it and distribute it through. Negative 4x, careful, times 2x.
Negative 8x squared.
Oh, good. Negative 8x squared. Does anybody have any questions on where I got the negative 8 from or where I got the x squared from? Good. So you saw that there was 2 x's, so it will be squared. Very good. And then negative 4x times by positive 3.
Negative 12x.
Negative 12, and I'm glad you didn't forget the x, because you're right, there was an x. Okay. Questions on that? Okay, I'm going to give you a second to wake you up, and you're going to work on problems 1. I don't have this written up here, but I'll write it real quick. 1, 2, and then skip to 7 and 8, and then we're going to get back to it. So you can do problems 1, 2. I don't know how I want you to move on. Why is it not writing? 1, 2, 7, and 8. I'll get it writing for a second. 1, 2, 7, and 8. All right, taking notes again, because this next part is a lot trickier, and there's a lot of errors when we get to stuff like this, okay? So looking at this, I have x plus 1 times x plus 2. You're going to see this forever and ever and ever for the rest of your life of mathematics, okay? So looking at this, notice this time I have a binomial, meaning 2 terms, multiplied to a binomial, meaning 2 terms. With this, we have to be really careful. These ones are a little bit trickier. So I'm going to give you a little suggestion that will help you never forget anything. Once again, draw your rainbow, because we have to be careful here. We have to multiply this to all of this. So I'm going to go through piece by piece. Now it takes an extra 5 seconds to draw the rainbow. Even I, with a math degree, draw the rainbow so I don't miss anything. So let's go through, focus on x, and let's distribute that through to each thing. So what's x times x?
X squared.
Good, x squared. Now I'm going to distribute that same x through to the other term, x times 2. Good, good, plus 2x. And now I'm going to go ahead, we've distributed x through, let's move on to positive 1, being careful. Positive 1 times x is plus 1x or plus x, same thing. And then positive 1 times by positive 2. Plus 2. Very good. And then from here, we'll combine like terms. So we have an x squared, no other x squareds, can't combine anything else with that. And then we have 2x's plus 1x, which is plus 3x's, and then plus 2. Now, once again, guys, it didn't take that long to just draw the arrows to make sure I don't forget anything, because when you try to eyeball it, a lot of times you'll forget to multiply something. Okay, so let's move on to the next example over here. X minus 4, this one's trickier. Once we get these negatives going, guys, we have to be so careful, and we're going to be really careful today. And not rush, like think before we do. So we have x minus 4 times x minus 5. The first thing I'm going to do is focus on my x here and distribute that through. X times x.
X squared.
X squared, you're awesome. X times negative 5. Negative 5x. Then I'm going to go ahead and now I'm going to focus on my negative 4, my second term here, and I'm going to distribute it through to each thing. Negative 4 times x. Good, negative 4x. And then negative 4 times by, careful, negative 4 times by negative 5.
20.
Good, plus 20. A negative times a negative is a positive. Let's combine like terms, but before we do that, before you answer, think very carefully. Don't just float things together, because we're getting better and better and more advanced at this. So we have x squared, no other x squareds. Now, careful, negative 5x minus 4x's. Negative 9x. Very good. Be careful, don't just float them together. So don't just see a 5 and 4 and say, that's got to be 1. Think about it. Negative 5x minus 4x is negative 9x plus 20. But we are getting better at this. And then we're done. Now, interesting fact for you. Watch so that you can make this connection later on. This is really cool. So everybody look at the answer I got here. X squared plus 3x plus 2. We took something that was peeled apart, we multiplied it together, and got back to here. Got up to here. Now, guess what? In a couple of lessons, not too long from now, we're going to learn how to factor. And it's starting here, and it's going backwards. So you'll start here, and you're going to work backwards and break it apart like this. And then you're going to break it apart like this. And we're going to learn that later. So that's called factoring. And it's just taking this big thing and then peeling back the layers and getting back here. So it's kind of interesting. We don't know how to do that yet. You won't. We're going to learn that later. So you'll be able to go back and forth. But they're equal. These are equal, guys, just different forms. Apples and apple juice. So equal, different forms. Apple, apple juice. Okay, continuing. Just an interesting fact. Okay, now I'm going to say, don't break the forbidden rule. Okay, the forbidden rule. Now, this is not a mathematical forbidden rule. It's a Miss Christensen forbids you to break this rule. So it's Miss Christensen's forbidden rule. And it's the most forbidden of all rules because guess what? 9 out of 10 students do break the forbidden rule at some point, and they get it wrong every time. And it just yanks my heart out. So let's go through what the forbidden rule is. So this is what people do, guys. They see x plus 2 squared. Now, if you were breaking the forbidden rule, this is what you would do. You would say, oh, so x plus 2 squared. Don't write this down, just watch. X plus 2 squared. Okay, so it's that squared plus that squared. Okay, watch. So x squared plus 2 squared. So what we really can do is just square that and square that. Okay, yep, all right. Simplifying this, x squared is x squared plus 4. That must be my answer. You just forbidden rule and you got the answer wrong. You cannot do that. You really can't, okay? This is the wrong answer. I'm going to show you when we do it correctly that you really don't get the same thing. Okay, so we can't do this. Now think about it. Side note, think about this. What is 5 squared? Now before you answer, I'm going to say, what does that mean? What does 5 squared really mean?
5 times 5.
Okay, 5 times 5. So with that in mind, we have x plus 2 squared. What does that truly really mean?
X to x. X plus 2 plus 2 times
X plus 2 times x plus 2. Does everybody understand how 5 squared meant 5 times 5? So if x plus 2 squared is x plus 2 times x plus 2. Now let's go through and double distribute this, and I promise you'll get a different answer. And guess what? The sad thing is, unfortunately, on an ACT, on the end of levels, if it was multiple choice, but mostly the end of levels isn't multiple choice, they know you're going to make this error. So that's going to be one of the options on an ACT. So you're going to think, I did it right. There's the answer. But don't break the forbidden rule, or else you've done it wrong. Okay, let's distribute this through. X times x.
X squared.
X squared, very good. And then x times positive 2
2x.
plus 2x, okay. Very good, you're awesome. And then positive 2, so I'm now going to this next term, times x is plus 2x. And then we have positive 2, times positive 2.
Plus 4.
Okay, you're awesome. Let's combine like terms here. We have x squared and then,
4x.
oh, plus 4x. Okay, you're good. And then what?
Plus 4.
Plus 4. So that's my answer. Is it the same answer as that? No, not good. Okay, so you can't break the forbidden rule. Okay. Next one. 3x minus 4 squared. Can we just square 3x squared negative 4? That'd be breaking the forbidden rule. Don't do it. So we know we can rewrite this real quickly as 3x minus 4 times 3x minus 4. This one's probably the trickiest one yet, so let's be careful when we go through this. But then I'm going to let you work for a while. So stay with me for a second. I'm going to let you work. So let's double distribute. 3x times 3x is 9.
X squared.
X squared. Beautiful. Everybody okay with y is 9x squared? Okay, so 3 times, so let's put them right next to each other real quick. 3x times 3x. So we can reorder that, right? So 3 times 3, and then we have x times x, right? So then 3 times 3 is 9, right? And then x times x, when you multiply the same base, you add the exponent, so x squared. I'm so glad you asked. Does that make sense, everyone? That was a trickier one. Okay, good questions. I'm so glad you asked. Okay, moving on. Now, 3x times negative 4.
Negative 12x.
Good, negative 12x, and we're not going to forget to write x. I saw so many people last hour doing that. They forgot to write the x. Okay, moving on. Now we've distributed the 3x over here, over to everything. Let's now focus on negative 4. Negative 4 times 3x.
Negative 12x.
Negative 12x. And then negative 4 times negative 4.
16.
Positive 16. You're awesome. Now before you go through and just say 9x squared, oh, 12x, 12x, they must just cancel out. No, we're getting better than that now because, you know, we're practicing. We're getting better at thinking before we act. So 9x squared, nothing we can combine with that. But let's think about this next part. Negative 12x minus 12x.
Negative 24x.
Yeah, negative 24x's. You're awesome. Any questions on that? And then plus 16. Okay, so just be really careful. Now, understand there are going to be times when your middle term does cancel out. We were sure on this one that it didn't because we did this right. There are going to be times it does. So you got to pay close attention to what you're doing here. Alrighty, now work on problems 1 through 8 on the worksheet for quite a while. I'll let you get some practice in and then I'll bring you back to me. So work. Learning, because now this is really cool. We're actually, oh wait, just a second. Okay. Are you guys must be, you are here, right? Or you guys switched on my team? I can't get it straight. Okay. Here we go. Moving on, okay? Now we're going to take, yesterday we had area and perimeter problems, right? We're going to take area and perimeter on a more advanced note today. Knowing everything we know, we built up to this point right here. Now don't let the word advanced say, oh, I'm scared, I'm in, just not pay attention, I'm not advanced. You guys, you're all very smart people. I've been very impressed. So let's go through this and you'll be good to go. Okay, so yesterday we learned that area means filling in the entire thing. Is that true? And then perimeter means adding up the outside. If you'll pay attention, you'll understand this a lot better. I'm going to say that again because I saw people not paying attention. Area means adding up the entire inside, filling it in. Perimeter means adding up the entire outside. So looking at this problem, we're asked to find the area and perimeter, and it wants us to write the area as a sum, write the area as a product, okay, and then write the perimeter. Well, looking at this, we're missing a lot of stuff, right? We're missing a lot of stuff. We're given enough information, though, to fill in all that stuff. Before we start doing that, I want to remind you, area is length times width. Area is length times width. So I want to focus your attention with that in mind, first of all, to just this piece right here. Looking at that piece right there, we have our length is 3x and our width is x. Could we find the inside here, area?
Yeah.
Length times width, okay. So what is 3x times x? 3x times x.
3x squared.
3x squared. So this inside here is 3x squared. Very good. I'm going to change colors so that we can keep our focus, right? Okay, so also think about this. Think about this. If this right here is x, then wouldn't this, since it's a rectangle, be x as well?
Yes.
Okay, let's write that in. And let's keep thinking. Let's keep thinking here. If this piece is 3x, then what's this piece?
3x.
Okay, and I'm just going to write that really teeny in there because that's not the inside. Well, if that piece is 3x, then what's this piece? Oops. 3x. Very good. Okay, interesting. Now this plus 2, don't let it throw you off. That just means positive 2. It's just specifying to you that that's a positive 2. So now looking at this, if we want to focus on this section right here, couldn't we find the area?
Yeah.
Length and width. Length times width. Okay, so what is the length times the width? 2 times 3x is
6x.
6x. Okay, awesome. You guys are great. We're almost there. Almost there. Now looking right here, if this piece is positive 2, then wouldn't this also be positive 2?
Yes.
Okay, so now looking at this, we filled in every piece. Just thinking critically. Okay, so now it says write the area as a sum. So this is the easiest one. We want to know the area as a sum. Area means adding up all the inside. So wouldn't that just be 3x squared plus 6x?
Yeah.
Do you see that?
Yeah.
That's the entire area inside, right? Can we just add that up? 3x squared plus 6x. Now, we can't combine those. Those aren't like terms. But that is a statement for area. Make sense? Okay. Now, the next part, it says write the area as a product. Okay, now we're talking the whole thing, guys. We're going to write the area different this time. It wants to know area as a product. What it means is we know area is equal to length times width. And we're talking the whole thing here. So we do know easily the width. What's our width?
3x.
So I'm going to put that where there's a W. That's 3x. Okay, but then what is the length of this?
2x. 2
Good. I'm glad I heard somebody back here say something I like. You said that to get this full length, you would do what? Adam, what's x plus 2? X. Nope. Hey, you just combined something that wasn't like terms. What's x plus 2? X plus 2. So you're saying that that entire length right there is x plus 2. True. That is true. You can't combine them though. That is true. X plus 2. So our length is x plus 2. So area is equal to, the length was x plus 2. So length, x plus 2 times width. Width is 3x. Now if you didn't put parentheses around length, you would get it wrong. You have to say length times width. So the parentheses say, you know, you're taking the entire length, x plus 2 times the entire width, 3x. So you got to put parentheses around anything like that. Okay, now that would be our final answer. This is length times width as a product. But look, if we multiply it through, we could check our answer because we better get the same area. It doesn't matter how you write it, it should work. So I'm going to check my answer real quick. 3x times x.
3x squared.
Good, 3x squared, and then 3x times positive 2
6x.
plus 6x. So we should have the same answer. They're written in a different form. I mean, this one was, but did we get the same answer?
Yes.
So we've done this correctly. Okay, but I want you to stop there. You can check your answer though. All right, let's write the perimeter. Writing the perimeter here, we need to add up all the outside. So you could do this a couple ways. I'll accept really, I guess, any answer. Just keep in mind you could write it a couple different ways. So if this is x plus 2, then this side is x plus 2. So now I'm going to add up all the sides. So I'm going to say I have 2x plus 2. Is true?
Yes.
Now this is a more complicated way. That's okay. It's thinking more complicated, I guess I should say. And then we have plus these two sides. So we have 2 what? 2 3x's. Very good. So that would be acceptable for perimeter. And if you wanted to add them up individually, I'm fine with that being x plus 2 plus 3x plus 2 plus x plus 3x, and then combining all like terms. I'll accept that as well. Does that make sense? Because really it's the same answer. We can multiply that through, right? And then combine all like terms. Does that make sense? Because some of you, I'm not so sure if it does. Okay, no questions. Let's do another one. Because that was a little bit trickier. Please ask if you have questions this time and watch carefully. So don't say, I didn't understand that one, so I'm going to zone out. Say, I'm going to watch really carefully and ask questions this time. Okay, this one we have to actually think backwards. That's why I put it on the board. You're going to have to be able to think backwards sometimes. So it is asking the same thing. Write the area as a sum. Write the area as a product. Write the perimeter. But really, we're going to have to kind of think backwards on this. So looking at this, we were given the area of that square is 20. We were given the area of that square is 8x, and we're missing a lot of stuff. We have to fill that in before we can do anything, really. All right, so let's focus here first. If the area is 8x, we know that area, to get to area, you do the length times the width. So we're going to be taking that times that, right? Well, what number would have to go here that if we multiply by 2x, we would get 8x? 4. Okay, good. Does everybody understand how I know that's a 4? Okay, so you can check it. 2x times 4 is 8x. I've done this correctly. If that's 4, then what's this?
4.
4, okay. And if that's 4, then this is 4 as well. Can I fit that in there? Okay. Now looking at this, we know area of this square is 20. We know that the length is 4, so what's the width? 5, because we have to be able to multiply those two things and get back to 20. Questions on how I got 5. Took a little bit of thinking, but now from here it's pretty easy to fill in the rest. If this part is 2x, what's this part? 2x. If this part is 5, this part is 5. Okay, so let's write the area as a sum. This is the easy one. Area as a sum means adding up the entire inside. So it's going to be 8x plus 20. Before you answer, think 8x plus 20. 8x plus 20, can we combine those? No. So we're done. That is 8x plus 20. All right, and then write the area as a product. Oh, this one we have to be careful. So this time we're writing it as a product, meaning length times width. That's a product. The length times the width. What is our length on this problem?
5 plus 2x.
Oh, 5 plus 2x. I'm so glad you didn't say 7x. You can't combine those. So the length is 5 plus 2x. So length is, I'm going to put it in parentheses. Now keep in mind, a mathematician would always write it in standard form, meaning the highest degree comes first. So they would write 2x first. 2x plus 5, which is the same thing, guys, as 5 plus 2x. And on an ACT, on the end of level, they would reorder it correctly. Does that make sense? I'll accept 5 plus 2x on my test. But do you understand how they're the same thing? Yeah or no?
Yeah.
Do I need to explain that? Okay, 2x plus 5 times the width. What's the width? 4. Now, once again, I'm just going to say this. A mathematician would write this as 4 times 2x plus 5, and it's the same thing as that, right? Okay. Last thing is perimeter. We could go and add up the entire outside. I'll do it that way this time. So I'll have 5 plus 2x plus 4 plus 2x plus 5 plus 4. Combine all like terms. 2x plus 2x is 4x. And then 5 plus 4 is 9, right?
Yeah.
And then plus 5 plus 4, so 9 plus 9 is
18.
So plus 18, combining all like terms. So I would accept that answer. I'd also accept the 2 times all that answer. Now remember, it might be a multiple choice test, and you have to be able to see it different ways. Can we think in different ways sometimes? Hopefully. That's what I'm trying to teach in this class. Okay, do we need another example like this, or do you think we're okay to work? Okay, let's go work then. Ready, set, go. Now understand this problem on your worksheet. This is for advanced thinkers. So it's a bonus problem. So I would push you to try it. This is a problem on your thing. You can write on it bonus, just so you know it's bonus. So that if you don't get to it, you don't get to it. I would really push you advanced thinkers to try it. I had someone do it last hour in 5 seconds. So it must not be. I mean, she's very smart, but I'm just saying it's not so advanced that you should all try it. Is what I'm saying. Okay. All right, finish that up.